In this last video for this unit, we're going to be looking at the 246 different phase changes, and we're going to look at some specific information about them, definitions, and whether they're endothermic or exothermic. So the arrangement of water molecules will become less orderly as water melts, and it will become more orderly as it freezes. I want you to think way back to video 1 where we talked about solids, liquids, and gases. Solids were very orderly. They were kind of stuck there. Liquids, they were able to flow and take the shape of their container. So they were not as evenly, distributed or whatever. So it makes sense to say that if it's going to melt, if something's going to go from a solid to a liquid, then the particles are going to become less orderly. And if you freeze it and go from a liquid to a solid, then the particles will become more orderly. Now, when you melt something, you go from a solid to a liquid. And we have already mentioned in the previous video that that is an endothermic reaction because heat needs to go into it in order for it to melt. And that means that the molecules will be moving more quickly in the liquid because liquids do have a little bit higher kinetic energy than solids do. As far as freezing, this is the opposite. So you have a liquid going to a solid, and in order for that to happen, it is exothermic, meaning that you have to take energy out of the liquid in order for it to kind of solidify, for the particles to go from less orderly to more orderly. They are going to be slowing down, so the kinetic energy is decreasing. But freezing doesn't always mean cold temperatures. We kind of associate freezing with cold temperatures because of where we are here in Indiana, but freezing just means something turns into a solid. So when things turn into a solid, for instance, at room temperature, we have several things that are solids at room temperature. That can happen at warmer temperatures as well. So keep that in mind. Freezing does not have a temperature associated with it. Every element on your periodic table has a different point at which it will turn into a solid. Moving on to some different phase changes, we have our liquid to gas phase changes here with vaporization and condensation. Vaporization is when a liquid turns to a gas, and this is endothermic because in order for the liquid to turn to a gas, it's going to have to absorb the energy, the heat from around it. Those liquid particles are going to be gaining kinetic energy to become less orderly because gas particles can freely move about and take the shape and volume of their container. Now this is where the heat of vaporization comes in. I showed that to you in the last video on one of our line graphs, but this is the amount of heat that has to be absorbed in order for the liquid to turn to a gas. And just like the heat of fusion, every compound or element has a different heat of vaporization. So where it turns from a liquid to a gas is different, and how much heat it has to absorb is different. So the same chart as earlier, this is your heat of vaporization. That's just from a liquid to a gas, and that heat, this temperature stays the same all the way through the phase change. But this is going to be a different temperature here for water than it would be for carbon dioxide, than it would be for the metal aluminum. Everything's going to be a little different. But they all have some heat of vaporization. It's just different for each one. Evaporation is the opposite of that. This is where your substance is going to be turning, it's going to be turning into a gas as well, but this is below the boiling point. So we have things evaporate even in very cold winter weather. Even close to freezing, you'll see some puddles as things kind of melt maybe during the day, and then the puddles shrink over time, and that's because the water is evaporating during the day when the sun's hitting it, and eventually the puddles completely go away. And that happens in the summertime too, a little faster because it's warmer. Evaporation happens at the surface of your liquid. So it's not boiling. Boiling happens all the way through. You can see the bubbles come up from the bottom and come up, but evaporation just happens at the surface. And the bigger the surface area, the faster it evaporates. So if you have a large puddle with a really, really long surface, it's going to evaporate faster than something that has a lot of liquid but just a little surface area showing. Boiling is another liquid to gas, so it's a type of vaporization, but this is again, going to be happening all the way through the liquid, where evaporation only happened at the surface. Your next one is condensation, and condensation is when a gas turns to a liquid. So this one's going to be exothermic. In order for a gas to go to a liquid, it has to cool off. So that means it has to lose heat. So it's going to be giving off heat for it to do that. Dew on the grass is an example when the water vapor that's in the air, overnight the temperatures will cool down, and that allows those gas particles to kind of collect on the grass. It also happens when you have like a cold drink, pop, maybe a can of pop, and you get that liquid water around it. That would be condensation. The last two are the ones that are probably the least familiar, people are familiar with, and that's because we don't really, there's not as many maybe examples that you see on a day-to-day basis with sublimation and deposition. But this is where, sublimation at least, is where a solid can turn to a gas, and it turns straight to a gas without becoming a liquid first. And so certain conditions have to be met in order for that to happen, so it's not something that you see, again, on a day-to-day basis. If you've ever seen dry ice, though, that's exactly what's happening. It's actually a solid particle, and then the vapor that you see kind of creeping around is a gas. And so it's going from a solid to a gas without becoming a liquid first. This is an endothermic reaction because it does need to absorb the energy in order to do that. And then the last one is deposition, and this is when a gas turns to a solid without becoming a liquid first. Frost on your windows is a really good example of this. Just the right temperature is met, and so again there's water vapor in your air, but instead of turning to just water droplets, condensation, it's cold enough that it just immediately freezes right away without becoming a liquid first. And this one's exothermic. In order for it to become a solid, it would have to lose energy, and the particles will become more orderly. As a gas, they're moving about, and as a solid, they're much more ordered and structured, so it loses energy in order for that to happen. And those are your 6 phase changes, and whether they're endothermic or exothermic. Again, let me know if you ever have any questions.